It is an unfortunate fact of life that old motorcycles mean old parts, and more specifically, old electrics. And the interactions of the space pixies going on in a motorcycle are beyond the reach of a lot of more mechanically minded folk. But one common problem is charging system issues. In my case, I have a bad regulator rectifier, and this is a very common problem on older motorcycles. And the symptoms here, which are fairly common, is if I start the bike and jump it, it'll run fine. It'll run for as long as you want it to, but then you shut it off and it won't start again, or it'll start extremely weakly. And the reason that's happening is because the battery is not charging, or it's charging weakly. The rectifier is just not pumping out enough voltage to top the battery off constantly, but it might be pumping out enough to keep the bike running. This is kind of an early stage sort of thing. Very common, especially on these older Ducatis. But fortunately, it is a fairly simple fix. Fortunately for the old bike connoisseur, there are parts readily available on the market and still being manufactured that you can use to fix pretty much any old motorcycle, which is what I'm going to be doing today, replacing the rectifier on my 1997 Ducati Supersport 900. I'm going to put this at the beginning of the video for those who don't want to watch the whole thing. Basically what we did was we took an FH012AA regulator rectifier from an 07 Yamaha R1 and completely rewire the bike using this rectifier. Yellow wires from the alternator go into the rectifier, black goes to ground out of the rectifier, and the red goes to a fuse and then straight into the battery. Keep watching, I'll show you how I did it. This is the main part. This is the regulator rectifier from a Yamaha R1. I believe this is from like a 2006 or so. This one isn't OEM. This is actually a cheap Chinese knockoff, which I don't recommend, but I'm going to see how well it works. If nothing else, it came with the plugs needed to make a really nice, clean installation, so I think that was worth the cost of the whole regulator. If this breaks, I'll just get an actual OEM one. But this is what's called a MOSFET regulator, or a FET regulator, I believe. It is an entirely different technology than what typically came on these older bikes. It runs cooler and puts less stress on the electrical system while outputting more consistent voltage. Good stuff all around then. So I'm going to be putting this right in my old Ducati, and hopefully this will fix up all my problems. Some other stuff I have here is red and black wire, 10 gauge, and also 10 gauge yellow wire, heat shrink butt connectors, heat shrink ring terminals. The gist of what I'm doing is I'm going to unbolt the stock rectifier and cut all the wires. I don't need any of the stock wiring anymore. On these Ducatis, it is marginally sized, if not undersized, for the amount of current going to it. So I'm going to be replacing or bypassing as much of the factory wiring as I can with this upgrade, thus the 10 gauge that I bought. I'll be running a red and black wire to my battery directly from the rectifier, and then on the other side of the motorcycle from the stator, you will have either 2 or 3 usually yellow wires. In my case, I have 2, but that's pretty uncommon. I'm going to cut those fairly close to the case and put in some bullet connectors and then run some fresh 10 gauge wire to the rectifier. Now, I prefer bullet connectors for this because there is more contact surface area than, say, spade connections. A lot of the times with the spade connection, you're not getting a whole lot of surface area contacting between the two pieces, and that can lead to a hot spot that can melt. One problem these Ducatis had was the factory plug going to the rectifier, which has already been bypassed on this, will get hot and melt from all the current going through. I think it's something like 70 volts AC. Don't quote me on that. I'm going to take this and put it onto here, starting with just unbolting this rectifier. Just a couple of 8mm bolts on here. On a lot of bikes, it's over by the seat or in the tail section, generally somewhere where it can get some airflow, because like I mentioned, these do get kind of warm. So the rectifier has been unbolted. You can see here the 2 yellow wires coming from my rectifier, 2 red wires going to the positive terminal on the battery, a white wire which I believe goes to the low voltage light, which is a function that I will lose by replacing this, and I think the black wire there is the ground. It also seems like it might ground through the case, which is kind of interesting. And then you've got a little ground on the ring terminal here. One nice feature, this has this backing plate, which I might drill a couple more holes into to better mount my new rectifier, I'm not sure. The yellow ones come through here, down, and over to the, where do they go? Over to the rectifier. Here we are. Yeah, those come down to here. I'm probably going to cut those by the heat shrink and put in some new connectors, make that all nice. The wiring seems to be in decent shape, actually. Sometimes you can get some corrosion in there. And then the red and black wires, looks like they actually have a plug. There we go. So there's our red wires. And I could just put one of these connectors on the new rectifier. I could easily move these over, but I'm not sure I want to use this factory wiring. It likely is undersized for the application. For the rectifier part here, I'm just going to cut the wires with a pair of cutters, use my strippers, and I'm going to put on these gold-plated bullet connectors for the lowest resistance possible. I've got my crimpers and my wire stripper. Not actually going to need that. These have their own insulation, so should be fairly easy. There we have a couple of happy little male bullet connections right there on the end of the stock wiring pigtail for the stator. I'm pretty happy with those. These were pretty much perfectly sized for this 10 gauge. And the polarity doesn't matter on these, so I made them both male, and also because the male ones have shorter insulation pieces that I could actually fit on the wiring here. So now I just need to make a little jumper to go from these to the new stator we're going to be putting in. So if you have 3, polarity still doesn't matter. It's alternating current. They can plug into the stator however you like. Here's the old stator. Yep, it's just kind of a big old lump sitting here. Not much special there. A few short minutes and a trip to the parts store later for some tools. Here's my finished little wiring harness for the stator. Already got the rectifier mounted up there. Just gonna go ahead and plug in this harness. It's plugged in and these cables are ran, and there's 3 connectors there in the bottom of this regulator, and it can go into any of those connectors that you want. So I'm just going to plug in these bullet connections here, and then that will be the source side all good to go. Can't do that with one hand either. So now that we have the power feed done from the stator, now it's time to do the actual power wiring itself. Now, this black connector here is the one that's going to feed power to the battery. There's only 2 pins in here. The inner one is positive and the outer one is negative. And for what I'm gonna do, I'm gonna run my power cable right here to where there's a bit of a negative bus so that I don't have to stack more stuff on here. And the power cable I'm going to attach to this secondary power lead that fed from the stock one but was crimped in as obviously aftermarket, but it is 10 gauge looking, so I think I'll be good to reuse that. And then I won't have to add another ring terminal onto the positive terminal. Trying to keep this a little bit neat and stock looking, so I'm going to whip up a negative power cable and slap that on. And just like that, we've got a negative cable, spade terminal on this side, ring terminal on this side, and that is just going to go right in there like that. Go ahead and pull off this, what is that, a 10, 12 maybe? Negative cable on the outside running along here right to this terminal, all good. Now for the positive, it comes with this 30 amp fuse. We're going to use that and some red 10 gauge, and we're just going to go to the positive battery terminal. And like I said, there appears to already be some aftermarket 10 gauge here. I'm just going to reuse this. Looks like it goes to wiring coming from the regulator. Yeah, that goes through here to the regulator. Looks like this sheath here had all that wiring in it, but I'm just going to cut and cap these. Not going to use them anymore because, well, I don't think that the stock wiring's in the best of shape after these many years. Ask me if this cable's done, I'll say that I'm positive. I debated a bit on whether or not I should make this a disconnection point, put another, say, bullet connector here, but I decided I didn't really want the resistance that would bring on my positive cable here, so I just kind of went along with it, and this is one solid piece. Now I just gotta run this over to the connector, stick it in, and we're good to go. There we go, all 4 cables ran. Make sure not to plug in your fuse until after this is all set up, so because this is a hot wire, or leave your battery terminals undone like I should have done. Now that that's all done, we can plug in the fuse and we should be good to go. Fire this up, see what we're charging at. This was previously just like charging at 12.4 volts at idle, maybe 13 once you get up in the revs. That's not enough to do it. It should be more like 14.5 or so. So we'll see where we end up with this as I button up a couple things here. Here's a pro tip if you're doing this. Buy legit parts. This is a $25 eBay regulator and it only put out 2 volts when I put it in. I paid, I think, $30 for this used genuine FH012AA and it works great. 13 volts at idle and about 13.8 when I rev it up to #loud because I don't have a working tachometer. But it charges the battery, it works fantastic. I'm gonna throw my fairings on it and go for a ride. And that's it. That's how you fix the charging system on old bikes like this. New rectifier usually does it. One thing that I did while I had this apart, I had the opportunity to hook a multimeter up to these 2 yellow wires. In your case, you'll have 3 probably. You can do this at any point if you have a plug in line, which this used to have, but it melted so it was soldered. Set your multimeter to AC mode, hook it up there, and start the bike up on the battery or a charger or something, and see what sort of voltage you get. I was getting about 50 volts, and that's what gets regulated by the regulator and rectified to DC in behind this heatsink here. So I was definitely getting enough volts out of the stator to sort of tell that that wasn't actually what was wrong here. So new stator, new wiring, bike is good to go. Moment of truth though, after all that riding, does the battery have a charge? Was it charging? Will it start?